derivative as a function. You don't need to worry about y. But all you need to worry about is that it is fun. We have something called the power rule. So if I give you something like this, look familiar? The power rule the exponent there is 1, correct? What's the exponent of the x here? If I had an x, it would be x to the 0, right? Somebody said it. So what did I do to the exponent? Yes, it's that easy. You can say it. I subtracted 1. Yeah. He's right. And then I multiplied this by 1. You can't see that, but so that's the power rule. Okay, so let's talk about g of x is x squared. Okay, what's g prime of x? You have to bring this out front. The 2 has to drop down. Subtract 1 off the exponent.
Wait, the 2 has to drop down?
Yes.
Oh, is that because?
So
we
here it was
multiplied-
1.
okay.
You didn't see the result of that. So subtract 1 from the exponent, drop the exponent down. If there's something out front, you would multiply. Okay, so like what is h prime of x? There, right? How much easier is that than algebra?
A lot.
Woo, done. See, I told you, derivative in 3 seconds is not 3 seconds, right? Easy, easier. Okay.
Just that, right? There's always a catch, guys.
What if I asked you to calculate f prime at 2? In this case, it is 7. Yeah, 7. That was easy. What is g prime at 2? 4. Yeah. He was plugging into the derivative. Could you write the equation of a tangent line?
Wait, that one's just 4?
2 times 2.
Oh, so you just subtract it again? Or we go down?
No, these are both the derivative. You're just plugging 2 in now. You don't make this too complicated.
Okay, yeah, that makes sense.
H prime at 2 is 96. So I could,
You just take the x forms, and then it's not the rest. So for example, 7x minus 9, and you get f of x, this, just I ignore the 9.
what is the derivative of a constant is 0. Okay, so no, I did not mention that. Keep that in mind. That's only if it's by itself. Okay. If it's paired with an x, it's not a constant anymore, so we don't go by that. Sean, what is the equation of the tangent line to G at x equals 2? Sure?
No.
So x is 2. What is this? Slope? What's my y value? G of 2 is,
4.
4.
thank you. So you were right, I just knew you weren't right.
Yeah, I wasn't all the way there.
So any of those questions continue to come, all right? So formally, we can write this what's f prime at x? Right? I can write this differently. This is standard notation for calculus. There is another one called Leibniz notation. It's handy. Leibniz. He is a German mathematician from a long time ago. Joseph Leibniz. Leibniz. I don't understand it. So,
No, this is the same thing.
is it a company?
It's a company.
Oh.
It's
Interesting. Well, he was a very famous calculus mathematician. He would write f prime at x like this. So this is the derivative of f with respect to x. You need to be able to write it this way. Because it shows up a lot. LEI, B, NIZ. Okay, so both of these are the same thing. They're just written differently. Get used to seeing that. I could also do this. What is y prime? So instead of having a function notation, I'm in equation notation, but I still use the prime here. How would I write this in Leibniz notation? B y dx. Oh, that's a 2-4. That's another 2-4, 45. So get used to writing in Leibniz notation. It'll become second nature.
Wait, so you just have to know, you just have to do df over dx, and then you can put what you solved from before.
What's the derivative? You might also see something like this. Where there is no equals, no equation. This means calculate the derivative of 10x cubed. Okay, so that basically is saying calculate derivative. When we started Leibniz notation, we have to end in it. You would write something like this.
So, for the power rule,
Yeah.
it still means that y is that way, it's gonna be some heavy.
There's a case where it doesn't work. Is there? No? think no, it's pretty good. There's a power rule for integrals that there's a case for that. So the power rule in general d over dx the derivative of some x to the n power, this is a generalization, is we bring the exponent down, so n x, and then subtract 1 from the exponent. That's so that's the general rule.
But shouldn't there be like a c in front of x, so it would be c times n?
If there was some number out here, yeah,
Okay.
but in general, this is just how it's written. Okay, let's see. Yes, let's look at one more example. Is that a power rule question? So when you get fractions, remember that exponent can be written as a power rule problem. Makes your life a lot easier.
So,
Okay.
if it's like 1 over x squared, is that x to the negative second?
Yep. Got it. Here in about a week, there's a temptation for people to call this a quotient, a division problem, and use the quotient rule. You get the same answer, but this is a lot easier. So what would this be? -1 x to the I almost always rewrite it. Because this is a lot easier. Like, where is this not differentiable? Here's the derivative, right? Not differentiable at 0. Whereas looking at this, it's a little harder to see that. Okay, so we have an exponent that's negative and a derivative, I suggest rewriting it. Alright, one more thing. You with me so far? I think you're like, dude, this is so easy, why you're killing the cat with it. This one's easy, which is why I inserted it today.
So it's going to be a lot.
Okay, this is not an exponent that we can bring down. If it's an exponential, we can't do the power rule. Okay, so be careful if the x is the exponent. But the easy thing about e to the x is that it's its own derivative. No, not any. Don't worry about this yet.
Wait, is e that one number?
E 2.71828. It's special, okay? As opposed to the derivative of 2 to the x, which is that. Don't worry about this. Don't even write it down. Okay? This is the only one where it's the derivative of itself. Okay? As you can see, 2 to the x is not the derivative of itself. It's close, but this natural x is on the front. Okay? So, Cage, you bored enough yet?
What?
Are you bored enough yet?
Ugh.
That was fun? think we're having fun with functions?
He said, no, it's fine, I'm living.
Okay. Let me get your work and see if you can maybe get some of this done.
Probably not.
But it's so exciting.
It's exciting because it's easy. Games,
Stick around there. Why?
Exactly.
Yeah, whew.
It's awful.
So
Yeah, yesterday, somebody was here.
Yeah.
I had that as for like, my back and yours, so like they're all these.
Yeah, a lot of writing, but I cherry pick these because they're the ones I see the most. Okay, the ones we'll see the most this year, we'll ask you to practice. Notice there are some evens. One, two, three, 4, 5, 6, 7 evens. So.
Is this due tomorrow?
Yeah. That's why I want to get your work in. So you have about 10, 12 minutes.
You have no idea.
Oh, there's a volleyball game tonight too.
Yeah. Okay.
That's rough.
Yeah, what about this tonight? Thursday night and Saturday, this weekend. I'm just skipping
Which
this
ones are
Saturday.
all?
Okay, Saturday night. 24? Is that 24? Okay, yes.
Yes.
Okay.
A lot of these are easy. Like number 2 is x squared plus 3x. What's the derivative?
I give up.
17,500,000.
Number 7. What's the derivative of x up to the 4th? You know what? I didn't mention that.
Which is -1.
More stuff.
Don't worry, guys. If you don't have that, you can just have to make English, just read, right? Just hope for the best. Do this, do this.
I didn't mention this
What is
notation.
that?
This is the same thing as saying, there's the function, calculate f prime at 1. That's all that's saying. So it's the derivative of x cubed at x equals 1.
So you find the derivative and then plug 1 in.
3x squared evaluated at 1 would be, so different notations.
Not sentence skirt.
Okay, Bilbo, that doesn't make any sense.
They were lazy, so they're doing notation, so they wouldn't have to write it. But not everybody else has to learn notation, and therefore they can't do lazy complex work. They have to memorize it.
I think you just complain about all the work and you have to do it.
Okay, quit complaining, start doing your work, so you go to volleyball games with a free conscience.
Yeah.
I did take a problem off of this assignment.
Oh, one.
Whole problem.
Wow.
No, it's off.
Would you like me to add it back?
It's fine. I'll take it.
Put your
It's better
snippet.
than nothing.
Whose it is? No idea. But I'll keep it.
Pretty fancy,
No, it's a fancy conversation.
I have an idea of whose it is, though.
Danielle's